Okay, today's video is looking at angles at a point. So there's a number of angle rules you have to learn. You already know two of them, looking at complementary and supplementary angles. So this is another one to look at. So the key thing we need to remember is that angles on a straight line add up to 180. We know that already because they're supplementary. However, angles at a point is both sides of the straight line, and in fact makes up 4 right angles. So it makes sense that the rule for angles at a point, or angles that meet in a central area, like the one in the middle there, add up to 360. So obviously they're not all right angles, so you can have other angles at a point. For that example 1 there, where you have an obtuse angle, an acute angle, a right angle, and a right angle. They add up to 360 because they're 2 straight lines. We've got an obtuse angle, we've got an acute angle, we've got an obtuse angle, and an acute angle. Again, 360. We've got 3 acute angles and an obtuse angle, 360. And the fourth one there is the obtuse, acute, acute. Acute again 360. So basically the rule is all of those 4 angles should add up to 360. So if we know their values, we can work them out. To visually show you what's going on with these angles at a point, there's a really good piece of software, GeoGebra, and we can move the angles around and have a look at them. So you can click on this link. It's also in the notes in the content library. Once you've clicked on the link, you should come to this page, and this is dynamic, so you can move things around. And what you can see, as I move this ray around, or the line, the angles change. The thing that doesn't change, though, of course, is 360. So it's showing us what the orange plus the green plus the red adds up to, and it adds up to 360. So you can see you can lengthen the line, shorten the line, you can move them around, obviously make them with a reflex, the red being a reflex angle, and then you can spread them out, but the whole time they always add up to 360. The other great thing that you can do is, now that you know they add up to 360, if I take one of them away, if I change these values to this, I can start to use it to work out what this angle on this other side is going to be. So I know that it should be 360, so it's 360, take away 91.3 and 130.1. You've got your calculators with you, you can quickly do that. So 360, take away 91.3 and 130.1, and we should get 138.6 as our answer. So if you want to have a play around with that, the link will be on the lesson page and also on the content library. Have a go at it, and you can try out some numbers and see if you can work them out as well. Obviously, if we don't know 2 of the angles, it's you can't work that out. Right. So now what we can do is we can start to look at working out actual answers. So what we've got here is we need to work out the size of angle A. So the way you need to write out your answers is A is equal to 360, take away 80, take away 75 degrees, take away 85. Then get your calculator out, and which leaves us with 120, meaning this angle is 120. It's always a good idea with these rules that generally then the diagrams aren't to scale, but they don't normally make them miles off. So the fact that we've got an obtuse angle there for A means that we should end up with an obtuse answer, which is 120. And yes, we should have got that. This one here, needs to remember that where there's a little square there. So our answer x, angle x, is going to be equal to 360 take away 90, take away 100, take away 105. On the calculator again, you can pause it if you want to make sure you can do the calculation, and then just turn it back on. And so the answer is 65 degrees. And that's it. So go back to the lesson page. There's a series of questions which I want you to attempt. If you want to go back and use that GeoGebra applet to play around with the angles, there'll be a link there as well.